Damien Despinoy, CEO, and Nikhil Chaudhari, the material scientist from Volexion, with a talk on conformal graphene encapsulation for high-performance lithium-ion materials. You're online. Stage is yours. Whenever you're ready, please go ahead.
Yeah, thank you very much. Good afternoon, everyone. My name is Damien Despinoy. I'm the Chief Executive Officer of Volexion. And today we're going to talk about our graphene-based technology to improve performance of lithium-ion materials. That's going to sound familiar because I think you've just heard from Nanograph, who focuses on the anode. But when you look at so we primarily focus on the cathode at Volexion. And so when you look at the configuration of a lithium-ion cell, so it's cathode, separator, anode, sandwiched between collectors, and stacked in multiple piles. And so why does the cathode matter? Well, when you look at a weight breakdown or cost breakdown of a lithium-ion battery cell, the cathode generally accounts for 40% of the weight of a cell, and on top of that, it also accounts for up to 50% of the cost of a lithium-ion battery cell. In addition, the cathode pulls a lot of constrained materials for which the supply chains are global and challenged. So, for example, that's where you find the cobalt, that's where you find the nickel, the manganese. So in summary, the cathode is expensive, it's heavy, and it has metals. That need to be harvested across the globe. So we think it's worth looking at this material and using our technology to improve the cathode and get to the next level of performance. Despite that, it is worth highlighting that over the past 10 years, there's been relatively little on innovation focusing on the cathode, since most of the innovation that's probably going to resonate with what you heard today, has been focused on the electrolyte, solid state, and on the anode. So that puts us in an interesting place. But enough introduction. So I wanted to talk to you about what we do at Volexion. And what we do here can be seen on the top right image, which is an SEM image of an NCA particle. So NCA is one of the nickel-rich chemistries that's commonly used in the industry. We don't make the NCA base material at Volexion, but we make the graphene-based encapsulation that you can see on the bottom right image. That's made of few layered pristine graphene, for which we have developed technology in collaboration with Northwestern University and Argonne National Laboratory to deploy a nanoscale, continuous pinhole-free coating that we can encapsulate, that we can deploy across a variety of substrates. And in our case, it's cathode material. So the resulting configuration can be seen on the top left schematic, where you have this nanoscale carbon-based, graphene-based coating that is engineered in a way that lithium ion can freely diffuse through the coating, while creating this completely isolating barrier that prevents the electrolyte from accessing the surface of the cathode material and prevents the transition metal from leaching out of the cathode material, because then they create cascading and crosstalk effects throughout the battery that are detrimental to the performance. So in terms of benefit that we provide to lithium-ion batteries, I think it comes in two categories, because we're really at the intersection of a surface protection technology and a conductive additive technology. So on the stability, what we routinely observe at Volexion is significant increase in cycle life of a lithium-ion battery. 2 to 3x is pretty common, what we see. Better safety, particularly for nickel-rich material, because of the oxygen, we prevent oxygen evolution that Nikhil is going to tell us about in a few minutes. And finally, we enable high voltage operation with current materials and with emerging materials. On the conductivity side, we see the benefit pretty immediately by reducing inactive materials and conductive additives in the lithium-ion battery, being an enabling technology for high power density and fast charge. And finally, because our materials with the coating comes pre-distributed with the conductivity benefit, it's also an enabling technology for dry manufacturing processes that are a significant topic of interest in the industry right now. I'll hand it over to Nikhil, who's going to walk us through some of the mechanisms that we observe thanks to the graphene encapsulation.
Hi everyone.